chapter will be on the circuit theory. So is there any one of you yang belum belajar lagi on the EPE ataupun memang tak pernah belajar langsung on the circuit, electrical circuit? Dah biasa. So V equals to IR, P equals to IV tu dah tahulah. Alright. So this is some sort of revision sahaja sebenarnya. Okay, but then kita akan tengok from the context for electronic, because we will cover in more on electronic part. Okay, like I've mentioned in our previous class. Okay, so for here we have circuit concept. These three elements yang important: voltage, V, and we have the current, I, also the resistance. Okay, voltage, current, and the resistance. Okay. In the context of circuit theory and electrical engineering, an element refer to a fundamental building block or component within a electrical circuit. So we have passive element and active element. Okay, and this thing yang resistance is the passive element. Okay, so rather than we have R, kalau you guys ada terbaca ataupun in other subject that you ada jumpa, we have C, the capacitor, and also we have L, the inductor. Okay, next semester you guys will enroll for okay, it's okay. Today's traffic is quite heavy. Okay, so in semester 6 you guys will enroll for MEC 522. I think the new code 524, control engineering. Okay, in control engineering you guys akan jumpa lagi dengan C and L. Okay, alright. So that one will be the passive element. Okay, the resistance, inductance. Kalau C is the capacitance, L is inductance. Okay, and for voltage and current, this one will be the active element. Okay, the voltage source, mainly the active element. Okay, why kita panggil the active element? Because it will provide and generate electrical energy within a circuit. So sources dia akan datang daripada this voltage. Okay, and then bila nanti we go for the KVL and KCL, you guys akan nampak lagi lah why kita cakap that one is the active element. Alright, so this is yang bawah is the circuit law, Ohm's law. What are Ohm's law? Tak suka betul lah benda bulat ni, nanti saya kena buang lah. Okay, apa dia? Okay, V equals to ingatkan nak cakap benda bulat ni macam mana nak buang. Biasa tak ada, tiba-tiba dia ada pagi ni. Okay, and then this is KVL. Pernah dengar the KVL? No. KCL? What are the difference between these two? Macam sama je kan? Apa beza dia? Semua tambah. Based on the polarity lah. Kalau dia terbalik, then kita tolak. Okay. Tetapi for the KVL, kita buat, nanti kita tengok lagi. Kalau KVL, V1 plus V2 plus V3. So it is based on the voltage. Voltage ni comes from where? Daripada sini tadi kan? Okay, that is kita akan buat IR. If the resistor ada satu, IR1 plus IR2 plus, tak sukanya bulat-bulat tu. Okay, and for the current, kita ambil I1 plus I2 plus I3. Okay, and for I ni apa? From here, I equals to V over, so setiap satu ni akan V over R1 plus V over R2 plus, and all together dia akan, tak mahu nak tulis dah, equals to 0 lah. Okay, this one equals to 0, this one pun equals to 0. Okay, nanti kita akan tengok more detail. And then we also have this one is on the resistance, series and parallel. So if you guys dah ada, any one of you yang tengok my notes in the Google Drive ataupun dekat, I think dekat UFeature, I don't upload on the tutorial. Dah ada tengok tak? Tak sempat lagi lah, busy betul madam first week ni nak tengok benda-benda tu. Okay, actually we have some sets of questions untuk tutorial. That one is more on the circuit theory lebih banyak lah. Okay, on the tutorial. And also, since in test we have 10 questions for objective. Okay, for the objective, soalan dia biasanya dia suka tanya on this. Kira resistor in parallel, kira resistor in series. Okay, kira on the voltage and current based on the KVL and KCL. So, please do not expect that since it is objective, it is will be boleh true and false. Boleh tengok, boleh pilih antara betul salah macam tu je. Tapi dia still ada some kind of calculations. Tapi simple je lah. Okay, some simple calculations. Okay, and also we will cover in chapter 1 is on Thevenin's theorem. Pernah dengar what is Thevenin's? Kenapa nama asyik semua nama putih je madam? Tak ada pun Yusuf's theorem. Haris. Siapa? Haris. Muksid. Yes, baik duduk depan. Every class I want Muksid duduk kat depan ya. Okay. So, Muksid theorem. Tapi Muksid nama dah canggih dah. Ali's theorem, nama Melayu. So, tak ada kan? Why? Because orang putih ni dia suka explore new thing. Orang bukan nak kata kita orang Melayu, kadang-kadang dia macam nature. Kita ni suka duduk tempat yang selesa. Okay, malas lah nak fikir lebih, penat otak, nanti terbakar kepala rambut. So orang putih dia memang nature dia suka create new things, dia suka explore new things. That is why banyak law ni comes from the orang putih punya ni lah. Okay, so ini adalah nama. Ni Pakcik Ohms, ni Pakcik Kirchhoff, ni Pakcik Thevenin's. Okay, so that is why dia punya theorems banyak nama orang putih. So this is all the things yang kita akan cover in chapter 1. I think, saya rasa lah, saya tak tengok lagi nota sebenarnya. Saya rasa ni je kot chapter 1. Ya tak Muksid? Apa lagi ada dalam chapter 1? Yes? Okay, so why we need all these laws ni, cara-cara ni semua? Because we want to allow and we want to in order for the analysis lah. Okay, in order to analysis one system. Kalau kita nak analysis system, kita nak tengok dia punya performance. How to measure the performance. This is based on the measurement. Nak measure voltage dia berapa, current dia berapa, what are the methods yang sesuai tu guna. Some situations sesuai guna KVL, in other situation maybe just can use simple Ohm's law sahaja. Okay, it depends on the situation. That is why to become an engineer, kenapa saya sebut engineer? Madam ni saya tak nak jadi engineer, I want to be influencer. Seronok je review barang, dapat barang. Okay, because you dah enroll dalam engineering punya field. If nak jadi influencer, then you can go for it. But then first you need to get your scroll, ada ilmu dulu. Ada ilmu, ada adab. Okay, so that is why lah. So kita nak ada all this knowledge. Okay, alah madam, saya mechanical, saya tak nak faham elektrikal ni just for the sake of nak lulus je. No lah, kita nak faham semua, kan? Okay, tak semestinya you ada mechanical, nanti you akan kerja in mechanical field. Boleh jadi your opportunity daripada another engineering punya field. Sekarang ni yang tengah glamour juga is sustainability, kan? Nak dapat green building. Tapi mechanical part, electrical part pun penting nak masuk dekat dalam the field background sustainability. Okay, alright. So this is all the elements yang kita akan belajar. Apa saya tulis kat sini ni? Dulu bila saya nak mengajar, saya suka tulis. Baca sikit. Allows engineer and scientists to design, analyze and troubleshoot electronic circuit for a wide range of application, from simple power supply to complex integrated circuit. Okay, yang complex tu tak apa. You will not go into complex. Tapi in order to, katakanlah nanti once you kerja, okay, please solve this circuit. Alamak, kompleksnya. Tapi if you have the knowledge from the simple one, then maybe you can solve for the complex one. Okay, that is why you need to understand on the simple one dulu. Okay. Tapi for the complex tu tak adalah complex bertingkat-tingkat. Bertingkat ni because for the electrical circuit, dia boleh jadi stage by stage. Okay, let's say kalau kita ada 1 BJT, remember BJT we will learn in chapter 3. 1 BJT kita cascade with FET. Dia ada banyak geng-geng TTT tu, nanti I will explain dalam chapter 3. Okay, kita boleh buat 2 stage. BJT, bipolar dengan field effect transistor. And then kita boleh jadikan 3 stage, ambil another one. Okay, stage by stage, it can be complex. Tetapi if you understand the operation on one stage, then you can buat datanglah 3 stage, 4 stage. Kita dah faham the fundamental kan. Alright. So tu baru satu slide kan. Banyak tu lah madam ni cakap pagi-pagi. Madam pun tak makan lagi ni ha. Alright. I'm sorry kalau dalam kelas saya mention kata madam ni asyik panggil je, madam tak suka saya ke? No. Saya ni susah sikit nak ingat nama. Okay, tetapi for some students yang maybe dah pernah masuk in my class, in previous class, ataupun kalau saya asyik panggil your name, you should be, oh maksudnya saya handsome, saya cantik, atau nama saya cantik ke, pakaian saya lawa ke, so you can attract my attention. Kalau dulu masa saya student, saya tak suka macam tu, saya kena panggil, saya kena jawab. Tapi sekarang ni tak boleh lah nak takut, saya tak marah kalau tak anda jawab. Okay, it just I need you guys untuk aktif lah, participate. Okay, alright. So this is gambar-gambar comel pula kan, kala-kala. Okay, this is yang this side. Ya Allah, geramnya bulat-bulat ni kan. This side, okay, semalam saya buat kerja pakai keyboard kot, dikuam dia bulat ni. This is for the resistors, elemen yang, kalau resistor tadi elemen apa, aktif ke passive? Okay, so this is passive. Okay, kenapa I just list down here for the resistor? Because untuk kat sini kita cuma for this MEC 523 we only cover for the resistor saja. But then there is also capacitor and inductor. Okay, and this one is on the power voltage. We have kat sini the battery yang biasa. Ni battery apa? Macam battery kereta. So this is on the active element. Okay, all the sources comes from these types of power voltage. Okay, so dah tengok gambar. Next we go for what is voltage and current. Okay, this is chapter 1 ni, this is combination in between theory part sikit. And also you need to understand on the theory part, only then kita boleh kira the calculation dia lah. Okay, so this is what is voltage and current. Kalau ayat-ayat yang panjang macam ni, please go through. Kalau saya macam sikit-sikit dalam kelas, please go through, baca balik, because we have soalan objektif in test. So for this soalan objektif, dia boleh tanya on this, what is voltage, what is current. Okay, and then biasanya A, B, C, D tu dia ala-ala lebih kurang je. Perkataan dia tukar 1 ke 2 ke, you dah macam yang mana 1 ya. Alright, so you need to faham, baca and faham semula. Okay, the two fundamental electrical concept in the field and electrical engineering yang important is voltage and power. Voltage and current. Okay, power juga penting, tetapi power, what is the formula untuk power? IV ataupun I square R. Okay, so nak dapat power comes from the voltage and current. So voltage normally we annotate as the V, current as I. If you come across any exercise ke, examples ke yang dia guna dia guna E untuk voltage pun ada. Okay, tapi E ni kalau dulu-dulu punya exercise, sekarang ni dah banyak guna V. Okay, yang lama punya dia banyak guna, dia adalah E. Kalau sekarang kita mostly dah guna E, but then this is the same thing. Alright, so let's see what is actually the voltage. Voltage is the measure of specific potential energy. Okay, energy, potential energy per unit charge between two location. Okay, between two node. Node ni dia macam satu point, between 2 point. Dia mesti ada different potential. So that is how we can get the value. Kalau satu point is 5, another yang bawah is, kalau ground is 0, meaning that 5. Okay, kalau kat tengah ada lagi voltage lain, then you kena tengoklah dia punya polarity, tambah ke tolak. Okay, the difference dia. Alright, so itu adalah the voltage. Represent the difference in electric potential between 2 points in a circuit. Okay, and for when a voltage source is connected to a circuit, the voltage will cause a uniform flow of electron, okay, through that circuit called a current. Okay, the one that I sini electron and current. In order to get current, dia datang daripada movements of the electrons. Tak nampak lah electron tu madam, macam mana nak bayangkan. Okay, memang tak nampak pun. Saya pun tak tahu macam mana nak tunjuk bentuk elektron tu, sebab saya pun tak pernah tengok bentuk dia. It just kita tahu the karakteristik dia. Yes, kita tahu karakteristik dia, electrons. Dia boleh ada electrons and also the host. You belajar benda electrons ni in chemistry, right? Chemistry nampak kan bulat-bulat, ada nucleus. Actually dia ada sikit, nanti we will touch dalam chapter 2 when we go to PN junction. Actually, kenapa nak kena faham the movements of electron? Because kita nak tahu macam mana boleh dapat the current. How we can get the arus tu. Okay? And movements of the arus ni comes from the movements of the electron. Electron dia bergerak. We can say, we can have majority carrier and minority. Majority electron, dia depends. Kalau ada P, dia depends on the jenis. Kalau N, majority dia electron, banyak E, banyak negatif lah, negative charge. Kalau P, positive charge, dia banyak apa, musik? Aduh, musik nanti sebelum keluar saya nak jumpa dulu Okay, and saya kenal dah dia, tu yang saya nak jumpa dia. Nanti yang lain jangan cakap madam ni dah ada favorite student pula. Nanti minggu depan, nanti kelas lain kita jumpa yang lain pula. Okay, and apa tadi? Okay, we have majority carrier, minority carrier. Kalau majority dia electron, minority dia auto akan host lah. Kalau in chemistry dipanggil proton kan. So benda sama je, elektron, proton. Kalau sekarang dia boleh jadi host, ataupun kalau in control, sebab saya pernah juga ajar control, dia panggil post and zero. So dia sebenarnya benda yang lebih kurang lah, cuma term dia berbeza. Alright, so in order to get in order to get current, movements of the electron. Okay, dia elektron bergerak, dia berlanggar ke, dia attract to each other ke, so because of that kita boleh dapat the current. Okay, so yang ini is just from the perspective. Madam, kan tadi kata V equals to IR, kenapa pula kat sini V equals to E over Q? This is from perspective of the charge over the energy. Okay, it is only on the theory part. Jarang sangat lah kita suruh kira guna elektrik, guna E over Q ni. Okay, this one yang kita akan guna. That is why ini adalah Ohm's law. Ini tak ada nama law ni, boleh siapa-siapa nak bagi nama dia pula. Okay, so this is untuk the theory on what is the voltage. Voltage is driving force that causes current to flow in an electrical circuit. That is why it is active element, the driving force, the sumber dia. Okay, voltage besar, dia akan effect on the value of the current. Okay, because normally resistance value dia dah fix. Okay, kita tak boleh nak adjust yang tu. Okay, this is apa gambar ni Mesti Muksik kata dah biasa tengok dah nonton ni, dah hafal dah pun. Kan? Okay, what else do we have here? This is analogy. Okay, voltage represent the potential energy difference that drive the flow of electric charges or the current. Electric charges is the current through a circuit. And voltage provides the push of driving force for electron to move, while current represent the actual flow of electron or charge in response to that voltage. So this is the analogy. This is the circuit that we have, open loop circuit. This is open loop sebab dia tak balik, dua tu dia tak cantum dengan satu node. Node 2 dia tak pergi dekat node 1 kat atas. Okay, so this is we consider as open loop. And this is the analogy. The directions of the arus, the current is in one direction, one way je. Dia macam air ni lah. So we have the air akan turun ke So ini naik atas okay, so this one naik atas. Okay, sorry, daripada ni sebab kita ada pump, so dia akan naik atas, only one direction. Dia tak akan lalu kot sini balik. Okay, same goes with the current. So for here, since positif bawah, so dia akan naik one way. Tetapi dia akan stop kat sini because open loop. If it is open loop, there is actually no current. So open loop, dia tak boleh nak flow, so we cannot measure. Kalau measure akan dapat 0. Okay, without return pipe. So how to measure? Macam ni. This is the pipe tadi. Ini yang pump. So kita kena pasang another pipe so that the water dekat dalam reservoir ni boleh turun balik dekat pond bawah, dekat tank bawah tu. Okay, so ia akan continuously all the time akan gerak lah, all the water flow, because kita ada pump kan. So dia akan gerak. Same goes with this circuit. So since we have this what we call battery, so dia akan move in one loop. So this is considered as closed loop. Saya tak suka lah. Saya rasa saya nak tukar dia macam ni sebenarnya. Positif atas. So from positif dia akan keluar daripada from positif. Okay. So this will be in a closed loop. Bila closed loop, there will be value for current. Okay, sebab the current can flow. Dia akan keluar dan masuk balik. Okay, so for this one, dia boleh, if untuk pump ni, dia boleh feed balik guna this pipe, masuk balik into the pump. For here, since we connect, tadi dia habis kat sini kan, so since we connect, ambil satu jumper, we connect from this node 1 and 2, so the current can flow in the circuit. Okay, so we can measure lah. Alright, so next, ni apa pula ni? Another analogy. Tak ada pula dalam nota saya ni. Ini masa saya tambah ni kan. Alright. Okay, this is considered as traffic analogy. Okay. Voltage is like slope or incline of the road. So let's say kalau kita ada bukit. Okay, ni bukit. Bukit. Consider as bukit ya. Okay, so this is from point A to point B. This one from point C to point D. Okay, so voltage is like the slope or incline of a road. The steeper the slope, the faster the car. Terbalik ni sebenarnya. Tak apalah. Okay, maksudnya for this one, A and B, kalau kereta nak turun, which one akan sampai lagi cepat? BA. Why? Because dia lagi cerun. Okay, meaning that ini adalah analogi untuk voltage yang lebih besar. Bigger voltage. Okay, for C and D is smaller voltage. Smaller source lah. Okay, dia lebih landai. So, kalau kita bawa kereta letak dekat N, yang B and A kita letak dekat N, mana lagi cepat sampai bawah? Okay, that one is on voltage and current. The kereta will be the current and the slope jalan tu, slope bukit will be the voltage. And another one we can have is nanti you bacalah cerita kat sini. Okay, kalau kita ada batu. Amboi batu lah. Batu. Okay, the stones, the obstacles. Obstacles we consider as the pandai. Saya tak payah explain dah. So, lagi banyak resistance, dia akan slower the car. Lagi banyak batu, akan slow lah kereta. Okay, so arus akan lebih kecil. So, dia akan depends on the value of the batu. Value of the resistance. Okay. Okay. In summary, dah ada yang download my notes dekat Google Drive tak? Notes yang saya upload dekat Google Drive. Dah, benda ni ada tak kat dalam tu? Nasib baik ada. Saya punya saya print ni tak ada. Dia masa saya letak ni Okay. In summary, these two concepts are fundamentals to understand and working with the electrical circuit and device. Voltage represents the potential energy difference that drive the flow of electric charges in the circuit. Okay. Provides push or driving force because dia adalah sources dia. Okay, dia datang daripada the source voltage tu. Normally voltage lah, jarang lah kita guna current source. Okay, and bukan jarang lah current source tak boleh guna. It just current source dia boleh represent what is the value of the current in the circuit. Okay, and the current represent the actual flow of the electrons or charge in response to the voltage. Okay, nanti on the charge electrons ni we will cover dekat dalam chapter 2 more detail. Okay, alright, so now kat mana separuh dia ni? Saya nak pergi separuh je ni. Okay, so now we will go for the Ohm's law. Ni senang je, you guys dah biasa tahu dah, tak payah cerita lah. V equals to IR. Okay, but then sometimes student dia malas nak tulis unit ni. Oh, unit dia yang ni je, A, Ohms and V. Malas nak tulis unit. Kalau masa saya marking tu, kalau saya back mode, nasib lah. Okay, tapi please lah tulis ada unit. Okay, unit V ke, unit A. And sometimes for the ampere current, you can write in normally milliampere, micro ampere, nano ampere. So boleh tulis lebih kurang macam tu je. For the resistance, we have kilo ohm, mega, dua ni je, jarang lah tera. Okay, rather than you tulis dalam 10 negative 3 ampere, so lagi better tulis milli. Nampak tak? Dia benda yang sama je, it's just on writing skills lah. Okay, and for voltage sama juga, it can be milliwatt, tapi jarang lah. Normally voltage dalam bentuk nombor biasa, nombor genap. Okay, alright. So ni pun tak ada apa. Kenapa senang macam ni pun masukkan dalam notes juga kan? Okay, so V equals to IR. This is the voltage source dia. Okay, the voltage source. So we have so dia sebenarnya nak macam ni, positif negatif. Yang tadi ni sebab dia positif kat atas. Laju pula. Yang tadi tu that is why I'm changing to positif belah atas. Okay, because the polarity, bila nanti when we do the KVL, dia penting to determine based on the directions from the polarity dia. Alright, so this one is, we have the resistor kat sini. So simply we have the voltage, we have the resistor, then we can get the current dia. Okay, as you compare between this A and B, what are the difference? Apa dia? What is your name? Israel. Okay. Kat mana saya tengok Israel lah? I think muka macam familiar. Okay. Okay, the resistance, value of the resistance is different.
Yes.
Okay, and then what will affect on the other value in the circuit?
The current value.
Current value. So, resistance kecil, current akan, because it is proportional kan? Yes, inversely proportional. So for this one, resistance dia besar, the current will decrease, dia terbalik lah, because the voltage kita maintain. Okay, so this is the obstacles. Obstacle dia banyak, so dia akan flow, dia macam filter. Dia dah cut dah sikit kat situ. Okay, greater resistor, smaller R for this one. This one, smaller resistor, greater value of the I, the current. Okay. And then this this one is okay. Nanti when we do the chapter 3, there will be IV characteristic. Okay, IV characteristic meaning that we plot the voltage and current. Sometimes ada yang plot I versus V. Okay, this is for IV characteristic. So, since this one is R is considered as the slope kat sini kan, V over I. Okay, the slope M is equals to the resistance based on this Ohm's law. Okay, this one tadi yang saya kata voltage symbol, sometimes you akan jumpa by uppercase E. Dulu masa saya belajar, zaman saya belajar dulu, bila kita tengok the material tutorial yang daripada lecturer lama-lama, so dia ada banyak juga tutorial guna E. Tapi sekarang ni saya rasa macam dah jarang, agak jarang lah jumpa. So mostly dah guna a V. It is the same thing sebenarnya. Okay. Alright, so this is sama je macam tadi. Okay, so another thing I want to show yang biasa tengok tak benda ni. Lagi satu macam ni. Apa beza atas dengan bawah? What's the difference? Atas AC, bawah yes. Okay, but then in our circuit simulation, bukan circuit simulation, circuit calculations, kita hanya guna DC. But then kalau if you do simulation, then you can use AC because dia akan effect AC biasanya dapat signal macam ni kan, so dia akan effect lah based on the current nanti. Okay, so ni apa ni? Bulat-bulat banyak ni. Fatihah, what is this? Simbol apa? Siapa? This one siapa nama? Faiti. Faika. Okay, what is this?
Simbol for source power.
Bukan source, bukan power, voltage. Voltage source. So we have banyak jenis. This one is AC, this one is DC. This is control, and dia boleh ada juga lagi satu macam ni. This one, bila dia ada anak panah tu, it is variable, meaning that dia boleh vary the value. Okay, dia boleh ada minimum and maximum. Okay, this is for current source. Ini, this one is VSS. Sometimes dia boleh jadi VCC, VDD, depends. VDD. Okay, and yang bawah ni pun sama. Some sorts of symbols lah. Normally when we do the simulation lah, bila nak buat simulation, dia banyak keluar simbol yang macam ni kan. Make sure you use the correct one. Okay, dia akan effect, especially in gambar yang macam ni and macam ni, AC and DC. Okay, why? Because kalau this is, let's say this is current I, kalau you guna AC, dia ada maximum and minimum, dia ada peak dia kan. So dia akan bagi vary value yang ada in range. So dia tak ada straight line. Okay, DC dia straight line all the time. For AC dia ikut phase dia kan. So ada positif, ada negatif. So in chapter 2 kita akan belajar. Madam ni banyak betul sebut yang masa depan. Chapter 2 lah, chapter 3 lah kan. Pandang ke depan. Okay, in chapter 2 kita akan belajar how to convert from the signal yang ni to get into this one, from AC to DC. Kita akan tengok macam mana sebenarnya, what are the operations, apa circuit yang kita boleh apply in order to change, in order to get the output to DC. Okay. Alright. Okay, this is series resistor. Senang je pun ni sebenarnya kan. Saya tak pernah tengok the syllabus yang you belajar ini PE. Tapi I think this one mesti you guys dah belajar kan. Okay. Alright. So, apa belajar kat EPE? Single phase, three phase. Yang itu memang on power memang kena belajar. Tapi on the electric punya circuit macam ni, apa yang you belajar? Kira apa? Kicau. KCL, KVL tu lah. Tapi on diode tu ada? Ya. Yeah. So okay lah, dah belajar juga kat situ kan. Okay. So this is very simple series resistor. So since now we have R1, R2, R3. This is kalau kita putuskan kat sini. Okay, so the total resistor is just combination of all the resistor. Tak kira lah ada berapa banyak. Okay, ni dia letak Rn sebab maybe dia boleh jadi beberapa lagi kat sini. Okay, and for the let's say for the KCL, okay, dia akan jadi V R1 plus bukan macam tu, sorry. For KCL KVL, dia sebenarnya sama je, tapi saya lebih suka guna KVL because when we use KCL, dia kena I is V over R. So dia akan jadi V over R plus V over R plus V over R. So dia macam banyak benda sikit. Tapi kalau KVL, IR plus IR plus IR. So dia macam senang sikit lah. Okay. So let's say okay, for KVL KVL okay, minus ni saya just tunjuk minus VS plus, why minus? Sebab kalau kita buat in loop, dia masuk kod minus kan, minus VS plus VR1, voltage dekat R1 sini. This is R1. V voltage R1. Voltage R2 start from here to here pula. Okay, plus VR2. Okay, let's say kat sini kita ambil plus VRN. VRN daripada sini to here sahaja. Okay, for VR3 equals to 0 because closed loop. That is why saya cakap tadi important is yang ni, the polarity dia. So kat sini memang kita pun kena buat minus equals to 0, one loop KVL. Nak buat KVL must be closed loop. Open loop tak boleh. Okay, so nanti since negative, bila kita nak solve yang negative VS tu, you bawa lah pergi the other side kan. And then V ni is minus VS. Tak muat dah nak tulis. Tak ada, saya tak letak pula page kosong. Okay, minus VS plus VR1 ni apa? Equals to I. Since it is series, I dia akan sama. Kat sini pun I, here pun I, this one also I, here also I. Series kan? So current is sama saja. So VR1 is equals to IR1. In total, this one adalah ni kan? So kita replace with IR1. Okay, lepas tu plus untuk VR2 pula, IR2. This is for R. Okay, and then kita buat pula plus IRN. IRN, VRN. Okay, next one is plus IR3 equals to 0. Okay, so IR3 is VR3. Okay, this is basic lah how to do the KVL. Sebenarnya KCL pun sama. Kalau KCL, kalau tadi kita ambil V, kalau KCL kita ambil I. Tapi lagi senang kalau guna V lah, because voltage source kita is V. Okay, alright. So this is for series resistor. Series resistor it is very simple, sebab current dia akan flow, yang flow tu sama je. Okay, and then bila kita nak solve macam ni, I dia kan sama semua ni kan, so kita boleh faktorkan dia. Kan? Alright. So bila kita faktorkan all I kat luar, dia boleh jadi macam ni nanti. Kan? All the R kita tambah, dia jadi R total. VS tu bawa pergi the other side yang negatif tu. Okay, so dia boleh you can relate between KVL with the Ohm's law. Kan? Betul tak? Pening lah madam, awal-awal pagi ni. Alright. Okay, that one is for I. For PT pula, power dissipation, it is power dissipation in each of the element. Sebab tu dia PR1, PR2, 3N. So P ni equals to I square R ataupun IV. So once dah ada I, dah ada V, dan kita boleh dapat the P lah. Okay, kalau dia suruh cari P, kalau dia bagi P and then dia suruh cari V, V suruh cari I contohnya, dia bagi P and then you manipulate lah. Okay, simple maths. Alright, so now we go to parallel resistor. Saya nak tengok kat mana saya nak stop ni. Okay, because in our study plan, week 1 and week 2 will be this chapter 1. So macam agak, tapi why I also don't want to go laju, because you guys kan week 1, week 2 ni nak tukar-tukar kelas lagi. Betul tak? So tak naklah push our accelerate laju-laju sangat awal-awal ni. Okay, so this is for parallel resistor. Just now kita tengok for the series. Now it is for parallel. Kalau for parallel, dia punya consider as pipe. Kalau kita ada pipe air, lepas tu pecah pada dua, dia akan pergi dua-dua kan? So sama juga for here. The current dia akan pecah. I total here, so sini, sorry, bukan situ. Mana dah? Alah. Okay, so dia akan pecah to here and to yang bawah. Yang ni bukan I2. Ya tak? Sebab I2 is here. So ni bukan I2. Kita mungkin boleh letak I apa? IX ke? Which is IX equals to I2 plus I3. Okay. So dia akan pergi sini I1, here is I2. Lepas tu sini is I apa ni? I3. Sebab dia tak ada bahagi dah. Let's say kalau belakang ni ada lagi, so it is not I3. Okay, so since dah tak ada, so that one is I3. Here is I apa? Sini I3. For here IX, ataupun you nak tulis I2 plus I3 pun boleh. It is the same thing kan? So it is gabungan branch dia masuk kat sini from I2 with from I2 with I3. Okay, dia jadi IX. And for here I apa ni? I total. I total is equals to baru nak tulis, dah ada dah. Okay, I total equals to I1 plus I2 plus I3. Okay, this one ni kalau kita ada oh betul lah, this one up until kalau kita ada more than 3 lah yang sini. Okay, so that is for current dia kan. So yang ini. Okay, faham? Okay, how about the resistance? This is for the resistance. It is not simply, kalau tadi the resistance is kita tambah je all the resistance because that one is in series. Okay, for parallel, kadang-kadang student dia selalu terlupa yang it is actually 1 over RT. Dia bila dah dapat tu terus jadi RT over equals to this one. Tapi must remember you kena bahagi balik all the total tu. So 1 over R1, 1 over R2 plus 1 over R3 plus 1 over apa semua. If it is in parallel. Okay? Simple je. Ni revision. Dah biasa tengok kan this thing. And kalau ada dua R1 and R2 sahaja, you can buat kan? And also you boleh tulis macam ni pun dia boleh terima, meaning that it is in parallel. Okay, tapi untuk ni kalau 2 je, if 3 then you can use this way. Tak boleh buat R1 plus darab R2 darab R3, lain jawapan dia. Okay, only if 2 parallel resistors. Alah, dah ada jawapan. Okay, kita tukar value. Kita buat this one jadikan 300 ohm. This one we make it 600 ohm. Saya tak tahu jawapan dia jadi berapa bila tukar ni. This one make it 100. Voltage dia jadikan 10. Okay, tolong kira. The attendance. Okay, anyone can give me the answer? Mungkin cari R total dulu. Oh, bukan R total. Okay, let's say if here is 10. So, R1 is equals to berapa? If the voltage source here is 10, VR1 is ten. Why? Why? Because it is same node. Same node. And then dekat dalam node tu tak ada any element. Tapi kalau ada element pun tak apa. Dekat sini, dekat atas ataupun dekat bawah dia tak ada any element. It is same node. So it is actually kat sini is 10, kat sini also 10. Tak kira how many resistor yang dia ada. Since dia same node atas dan bawah, ada 100 pun semua 100. Okay, itu adalah that concept for parallel. So VR1 equals to 10 equals to VR2, semua sama lah. Alright. So our total, what is the value? 66.67 ohm. Okay. Alright. So this one is contoh-contoh for resistor. Sometimes from time to time I'll upgrade my notes. Bila saya upgrade my notes yang saya print awal-awal dulu tak ada. Okay. So this is okay. First tengok yang atas. Kecil ke? Okay. Tengok this one. Yang atas ni. So this is parallel. Sebenarnya yang tadi ni boleh lukis macam tu. Kita boleh kalau nak lukis tarik one knot macam ni, pergi ke voltage. Sama tak? It is still same knot. This one. Kan? Bila kita simplify dan dapat yang the original tadi. So same goes with this one. This is parallel the 2R. So this one is bila kita solve this 2R, dia boleh dapat R over 2 sebab dia R plus R kan. Okay. So dia kalau 2 lah, tu yang dapat ni. Kalau 3 lain lah pula kira dia. Alright. So that is for resistor. This is yang bawah also cara lukis all the resistor for parallel. If this one, the first one, kalau kita tarik, this is one knot, this is also satu knot, kan? So this is actually sama dengan yang ni, ataupun simply macam tu, kan? A and B. Same goes for this one. Kalau dia tambah lagi banyak. And also this one boleh tarik macam ni juga. Sama je. Okay. This one lah. This is number 2. And this is number 3. This is 4 and 5. Yang number 4 pun sama. Atas dia is this same note. Bawah is also same note. Pentingnya for you guys untuk tahu baca on the same note ataupun tak, because kita nak determine macam ni lah. Betul ke dia parallel or it is actually series? And in chapter 4, boy madam tadi dah pergi sampai chapter 3. Dah first week terus pergi chapter 4 dah. In chapter 4, you akan belajar in the logic gates. And or no. Okay, that one pun penting untuk kita baca it is actually same note ke tak. Because kita nak tahu after that gate dia akan pergi ke mana. Okay, dia akan inject dekat what stage the next one pula. Okay. So this is one note. This is one note yang atas. Okay. Yang number 5 ni macam mana? This is sama kan? Dia sentuh semua. Dekat sini, from here dia pergi A. This note also goes to B. This note also goes to C. And belakang dia, let's say this is point 1, this is point 2. This note goes to point 2. Point 2 also comes from B. Also comes from C. Okay. And this one, kalau kita, saya tak boleh pusing. Saya boleh pusing macam ni. Kalau kita pusing, dia akan jadi kalau kita pusing, dia akan jadi sama macam circle yang atas tu. Bila kita tengok from this direction dengan this direction, kan? Dia terbalikkan. Baring dengan bangun. Okay. So that is for parallel resistor. Okay, let's do this exercise dulu. After that, I want to stop the recording. Nanti panjang pula recordingnya. Okay, so this is dah ada jawapan senangnya. Because actually before this, my notes dalam kelas saya guna PowerPoint. Bila PowerPoint kita boleh next baru keluar ada jawapan. This one here, since saya nak conteng, so I make it PDF. Bila PDF dia keluar terus all the jawapan. Okay, tak apa. This one, kita fahamkan dulu all this. What do we have in here? Kita ada 10 volt is the power supply, voltage supply. Voltage supply. Lagi more specific, DC voltage source. Okay, and then kita ada first thing is the R1. Yang ni kita letak R1 lah. Tak, bukan R2 lah sebab dia I2. Okay, tak apa, kita letak R2. Okay, and here we have yang ni, yang 8 ni, it is, we put it as R8. Okay, this one yang 6, it is R6. Okay, ini adalah R2 juga. Sekejap I2. Ni V2. Tak apa, this one is R3 lah pula. Okay, here is R4. Okay, so I2 dekat sini. Okay. Alright. So for this one, I8. How many loops do we have here? 3 loops kan? So we can make it 1 loop, second loop, third loop. Okay. Which one yang paling first kita boleh solve? Okay, kat sini dah ada, sini dah ada V2. So V2, for V2 dekat R3 tu dah boleh dapat belum? This one, because it is given the voltage kan? Dapat tak? 3.38 mili darab 2K. Dapat tak this value? V2. Tengoklah antara all this I2, V6, R4, yang mana paling, yang mana dah boleh kira terus? I2. How to get the I2? V over R. Okay. And then what else boleh dapat? V6 pun boleh juga kan? V6 I R kan? R4 R4 we have the this one 3.38 the current akan flow sama kan? Okay, equals to V over kan? It is given 13 tu. Okay, boleh? The R4. How about V2? Ni, we have the current, so equals to IR kan? How about the I8? I8 V over R kan? Okay, saya nak tunjuk one way untuk kira. Tolak 10 plus I2 2K plus I8 8K equals to 0. This one ni datang dari mana? KVL for KVL for loop mana? Loop Loop 1.
Loop 1.
Okay. Dia lalu sini, pergi sini. I2 darab 2K. Lepas tu dia pergi sini. Since it is given I8 dekat sini, so here is I8 darab dengan 8K. Lepas tu pergi sini, dia kena masuk balik dekat mana dia keluar. Apa lagi dia jumpa? Tak ada dah. Okay, bila tak ada equals to 0. Equals to 0 meaning that closed loop. Okay. And then kita boleh katakanlah this one kalau nak cari I2. Okay, so I8 yang ni dah ada tadi I8. So kita masukkan this one I2 2K equals to 10 minus I8 8K. Okay, I8 8K sini kan 10 ni kan. Oh sorry, kat sini dia letak negatif. So I2 dia kena terbalik. Kenapa? Sebab dia bagi negatif. Kalau dia tak bagi, kita consider it is positif. Since it is given kat situ negatif. Kalau kita tak take into consideration, sekejap lagi bila kita kira, dia akan jadi negatif. Jadi yang ni 10 tolak this one. Sebab dia nak V ni kan. V dekat sini. V in here. In the green box. Which is equals to kan 10.59. Jadi dapat berapa? 0.59 kan minus. So kat sini if kita nak ambil I2 over 2K, cuba bahagi, dapat tak? Dapat berapa? $0.59 over 2K. Berapa? What are the value? Faika?
But 2K tu in kilo habis.
2K lah.
2.95 times 10 kuasa negatif.
So tukar.
Tukar jadi
Dia sebenarnya calculator sekarang saya tak suka sangat. Dia macam tu 2.94 darab 10 kuasa negatif 3. Tapi bila you write, kita tak potong markah. As examiner kita tak potong markah kalau dia tulis macam tu. Nombornya betul, tetapi untuk kalau nak increase your knowledge, bila student tu tulis 0.295 milliampere, kita terus okay, dia dah faham. 10 kuasa negatif 4, it is equals to 0. milli, something in milli. Okay, tapi jawapan tu tak salah. It just you kena enhance sikit thinking tu. Okay, sebenarnya dia milli.
0.29
milli. Yes. 0.295, tak mahu nak tulis milli. Sama tak dengan ni? Sama kan? So ada dua cara lah boleh guna. Bukan dua cara. This is the simple way macam ni. Tetapi when we do KVL, we can get the value sama. I just want to show to you guys lah KVL punya cara. Okay, nampak tak? Buat apa nak kena susah madam guna KVL? Yang tu kan senang je. Kalau dia given the value, then you can use simply macam tu. If it is not given, then kita kena buat KVL. Kan? Okay? Alright. Ada pun meja kosong pula, tempat kosong saya letak. Okay. So, I think I want to stop here. Tak banyak dah pun sebenarnya. Kita stop kat sini lah. Any question tak? Bukan tak banyak. Ada lagi tapi I think we will stop here. Any question from you guys? Is there any question? Tak ada. Senang sangat belajar hari ni.